Okay, good morning, everyone. So, do you have any questions before I start? All right, so today we're gonna go back to section 4.1. Sorry, I meant 4.9, and we study antiderivative. Antiderivative. Okay. So let us recall from yesterday what we did. We said that suppose you have a function f, let f be a function. Then big F is an antiderivative of little f if the derivative of f is equal to f. So basically, we have a function f this time. Big F is an antiderivative if, so from here to here is differentiation. So f is antiderivative. When we differentiate f, we get little f. And now our goal is the following. If we have little f, how can we find big F? So we're backtracking as we said yesterday. Now, so the first example we did yesterday was the following. So suppose f of x is equal to x, then an antiderivative of f, we figured out yesterday that it was a half x squared. And then we start asking, are there others? And we realize that there is, every time you add a constant, you don't change the derivative. Every time you add a constant, you don't change the derivative. And geometrically or graphically, it makes sense because if you have this function, that's a half x squared, shifting it up or shifting it down will not affect the derivative because the slope of the tangent will be actually the same. Okay. And then we said that because adding constant doesn't change the antiderivative, so if function have a lot of antiderivative, so we talk about what we call the most general antiderivative of f of x equal to x is half x squared plus c, where c is a constant. C, a constant. Constant means it doesn't depend on x. X is my variable here. Constant, it means it doesn't depend on x. Okay, so whether a function have one derivative, because it's the slope, so we have one slope, but it has a lot of antiderivative because of, as we said, shifting up and down will not affect the slope of the tangent line. So today our goal is actually to learn slowly how to find antiderivative. So we have to build a pattern, of course. And so let me ask you a simple question. I mean, suppose I have f of x equal x squared. The question is find an antiderivative of f. Okay, so I want you to get started and give me idea. So I want you to find me a function. When you differentiate, you get x squared. Okay, get going.
Right? 1/3 x to the third.
1/3 x to the power third. Is he right? And why it totally makes sense? Because if you want x squared to be the derivative, you have to start with x cubed, because derivative takes away 1 power. Okay. But if I only take x cubed, as we did yesterday, this is going to be 3x squared, the derivative. So I divide by 3 to compensate for that. And then I get x squared. Okay, so f of x is going to be 1/3 x cubed. And like we did yesterday, plus 1, plus 2. So we're going to write plus c. Okay, so here's the rule. an important note. A function can have a lot of antiderivative, as we realized, because adding constant will not change. But this is the theorem. If a function if f has two antiderivative, if a function have two antiderivative, f and g, so how can this happen? The only way this can happen, the only way a function can have antiderivative, those two antiderivative are nothing more than a shift of each other. Okay, so a function can have a lot of antiderivative, but they are all related. The way they are related is one is a shift of another. It means if 1/3 x cubed is an antiderivative, the other, we can have another one, but it has to be a constant. So I cannot have a function of x in here. And that's always the rule. So if a function has two, it means that one is absolutely a shift of the other. Now,
so that plus c, that's an answer that's required as for the answer.
Yes, so because why? There is two reasons. One, we're gonna really do it today, hopefully, if I have time. Because why 1/3 x cubed? It could be 1/3 x cubed plus 1. Mm-hmm. Right? Why not 1/3 x cubed plus 2? So they are all antiderivative. To capture this idea that we have a lot of them, we say it is plus c, where c is a constant. Okay? Let's capture the idea that we have a lot of them. So that's why we add the constant, just to tell you that. All right? And hopefully, if I have time today, we're gonna kind of play a little bit more with this idea of a constant. But minus c, it doesn't really matter. I mean, you can put minus c. That's also a constant. So this you can put, as long as you add a constant, it means does not depend on x. That's really what I meant. Do you have to call it c? No. You call it k, you call it d, you call it anything under the sun. I don't care. I don't think I care about that it is a constant. That's really what matters.
Would it also go the other way around? So could it also be g equals f plus c?
Of course. Okay. It doesn't matter. The only thing is that one is a shift of the other. That's what it is. How do you want to write it? I don't care. Even a lot of books write it like this. F minus g is a constant. That's another way you write it. I mean, they change by a constant. That's the only difference between them. So we can have 1, 2, but that's what's happening between them. They are a shift of each other. Okay? How you write them, I don't care. That's the idea. One is a shift of the other. All right. So before we start finding them, I have to introduce the idea of indefinite integral. Indefinite integral. Okay. Now, in math, we introduce symbols to represent ideas. So here we say like an antiderivative of f is this. So indefinite integral is a symbol that next section I will explain where it comes from. It's a symbol that would represent the antiderivative. So instead of saying an antiderivative of f is this, we're gonna introduce a symbol which represents the antiderivative. And the symbol will be called indefinite integral. So what's the indefinite integral? The indefinite integral is nothing more than a symbol that represents the derivative. So we're going to use the following notation. The following notation for antiderivative. Okay, that we're going to call indefinite integral. And the notation is this. Think of this as an S, as a letter S that you stretch it. That's really what you have to think about it. So of f of x dx. So you have to accept the notation and you have to use it. This is called indefinite integral. Now where the notation comes from will be very clear next section, but now we have to start getting used to it. So we use the following notation for antiderivative. So f of x, integral of f of x dx is nothing more than the antiderivative of f plus a certain constant. I'm going to write constant, but usually we write c. Okay, so that's nothing more than a notation, nothing really deeper than that represent the antiderivative. So instead of saying the antiderivative of blah, blah, blah is this, I say the indefinite integral of f of x dx is that. So with this new notation, because it makes writing kind of simpler, with this new notation, the indefinite integral of x squared dx is nothing more than 1/3 x cubed. It's nothing more than the antiderivative. The indefinite integral of x dx is nothing more than 1/2 x squared plus c. So that's really the notation. So with this pattern, what do you think the indefinite integral of x4 dx is going to be? So it means what is the function? When we differentiate, we get x4. You guys see the pattern. So I'm listening or reading, whatever. Exactly, because I need x4. It means it's x5. The derivative takes away a power, so x5 is the best candidate. To compensate for the 5, we are doing this. So this is going to give me 1/5 x5 plus c. Okay. All right. We're going to come up with a rule, of course. But before that, let me explain one thing. What's the antiderivative of dx? First, what does this mean? That's really confusing at this stage. Antiderivative of dx, or indefinite integral, I use them as the same thing. This means antiderivative of 1 dx, means the function here is 1. That's really what it is. So now the question is, what is the function whose derivative is 1? Okay, so integral of dx means that the function in question here is f of x equal to 1. And this is equal to what? Absolutely x, because the derivative of x is 1. Okay. Now, this pattern, of course, antiderivative of x squared is 1/3 x cubed, antiderivative of x4 is 1/5 x5, suggests a certain rule that we're going to call it the power rule for antiderivative. And that's going to be the first rule we're going to have today. So first rule is the following. And this is definitely, total memory. Okay, so power rule for antiderivative. Antiderivative of, in general, x to the n dx. So like we did for derivative, we found what's the derivative of x to the n. It was n x to the n minus 1. Now basically we're reversing. So now my question is, what is the function? When we differentiate it, we get xn. So that's really the rule I'm going to build. So based on the pattern, derivative takes 1 away. So if I want to find a function whose derivative is xn, I have to add n plus 1. That's crucial. And now, but the derivative of x to the n plus 1 is, derivative of that is 1/n plus 1 times x to the power, sorry, my mind went blank. But the derivative of this is n plus 1 x to the power n plus 1 minus 1. It means n plus 1 x to the n. If I put x to the n plus 1, that's going to be my derivative. To compensate, we divide by n plus 1. So by doing this, I get x to the n. Okay, so the antiderivative of x to the n is going to be equal to, and you will see why I'll do that, 1 over n plus 1 x to the power n plus 1. Absolutely, totally under memory. We don't have at this stage to confuse differentiation versus anti-differentiation. So if I take this function, differentiate it, we get that. Very good. This is the formula, but this formula has a problem somewhere. Where is the problem? Where is the problem? I want you to stare at it a little bit and tell me where is the problem.
If it's a negative number.
Absolutely. Not negative, a specific negative number. A specific negative number. Which specific negative number? Every time we divide, we have an issue. If n plus 1 is equal to 0, it means if n equal negative 1, this makes no sense whatsoever. So this is going to be the rule as long as the n is different than minus 1. Because if I put minus 1 here, this is nonsense. So now the question is, what happens if n is equal minus 1? So let me isolate this and then I'll put the answer here. What does it mean n equal minus 1? Means what's the antiderivative of x to the minus 1? But x to the minus 1 is 1 over x. So what's the antiderivative of 1 over x? It means what is the function? When we differentiate, we actually get 1 over x. Back to you now. That's the ln of x. Okay, so now if n equal minus 1, this rule falls apart, and that's going to be the ln of x. Okay, so if n different from minus 1, that's the antiderivative. If n equal to 1, this is the ln function. Now I'm going to not explain this very deeply, but I want you to accept it from me. It's actually the ln of the absolute value of x, because sometimes we're going to need x to be negative when we're working with those antiderivative. And if x is negative, it doesn't make sense. So we can prove that even if I put ln of the absolute value, we can show that its derivative is also 1 over x. So you accept that from me. But the idea is that it is the ln of x. Okay, so the first extremely important rule for the antidifferentiation is the power rule. It's 1 over n plus 1 x to the n plus 1 in this scenario, ln of x if n equal minus 1. So be very careful, do not have 1 over 0. It doesn't make sense. So let's practice this rule tiny bit. Okay, so let us do some example. Very basic one. So let us find the antiderivative of or the indefinite integral, which is easier to write instead of writing antiderivative. So we can do very quickly a very simple one first. And the question is find and check. Find and check. Okay. And log of x5 to dig x. So here my n is equal to 5. So it's going to give me 1 over n plus 1 x to the n plus 1 plus c. Okay. And we check. Even though that's fairly simple, but we check. Equal 1 over 6. Antiderivative of x to the 6 is 6x5 plus c is 0. Remember, c is 0. That's why it's derivative, x5. Okay. So now let's do another one. antiderivative of 1 over x squared dx. Now we're going to do exactly what we did for when we differentiated. Whenever I have 1 over x squared, we can rewrite. So we're going to rewrite first, because I cannot make up rules from my own. The only rule I know so far is x to the n. So if an expression doesn't have this format, I have to write it to have this format. So this is going to become the integral of x to the minus 2 dx. Now I can use my rule. N is minus 2. So this is going to be equal 1 over minus 2 plus 1. Anti-differentiation, you add 1 to the power plus my constancy of integration. And that would give me minus 1, because minus 2 plus 1 is minus 1, x to the minus 1 plus c. So we totally, which is minus 1 over x plus c. Totally reversing the process. So now we check. What's the derivative of that? Minus 1 over x is minus x to the minus 1 plus c, which is, what's the derivative of that? It's minus 1 x to the minus 1 minus 1. Now we're differentiating plus 0, which is 1 over x squared plus 0, 1 over x squared. Okay. All right, one more, and then we keep working with the properties. So the last one, antiderivative of cubic root of x dx. Again, I have to rewrite, because as we said several times, calculus doesn't like the root. We rewrite everything using fractional exponent. And the third here, and this will give me 1 over a third plus 1 x to the power a third plus 1 plus my constancy of integration. And now a little bit of algebra. A third plus 1, which give me 4/3, x to the power 4/3 plus c. And this will give me a little bit of algebra, 1 over 4/3, a 3/4 x to the 4/3 plus c. Okay, and then you guys can check it. I will not check it myself. Right? So these are the antiderivative of a lot of the power function. Now, properties of the antiderivative or property of the indefinite integral. When we worked with derivative, okay, we first did the power rule for derivative, and then we start saying, okay, if we know the antiderivative, the derivative of x squared, now we want to know what's the derivative of 4x squared. And we have the rule that the derivative, if you have a constant k, the derivative of k times f, you pull the constant and you times it with the derivative of the function. So if I want 4x squared, the derivative will be 4 times 2x, which makes finding derivative of a more and more function possible. And then we say, okay, what if we add 2 functions? What's going to be the rule? And then we state that the derivative of the sum is sum of the derivative. So these are the 2 properties for derivative. Indefinite integral will have very similar properties. Okay, they'll have exactly the same similar properties. So what are they? The following is the following. If you have a function f, and you can multiply it by a constant. I use k for constant. So here k, and that's crucial. K is a constant. It's not a variable. It doesn't depend on x. So k is a constant. Very important. And then the rule is that you can pull the constant out. The constant can be pulled out times the antiderivative of f of x dx. So fairly similar properties for differentiation. And then the other property is, if you have, you know the antiderivative of f, you know the antiderivative of g, you add them, you create a new function. And the antiderivative of the new function is the antiderivative of f. So now we can have more and more function. We can find an antiderivative plus the antiderivative of g. Okay? And those two rules were going to allow us to find the antiderivative of a large class of functions. So let us apply it immediately. So for example, of course, I start with a simple one. Find the antiderivative of 2x cubed. Okay. Now, 2 is a function. Sorry, my apology. 2 is a constant. Only constant could be taken out. So I can write this as a 2 multiplied by the antiderivative of x cubed. Okay. And now this is 2. Is it 2? Antiderivative of x cubed. Now we know this one. It's 1 over 4 x4 plus a constant c of integration. Usually it's called this constant c of integration. So it's going to give me a half x4 plus c. Okay. Let's do 3 more along the same line. For example, integral of 5 plus 3 over x dx. Okay. So this time I have a sum, and the rule tells me if you have a sum, and you have only two, if you have a sum you're adding, you can break it up. So if you have a sum, you can break it up. So this tells me that I can break this up into 2. So it's integral of the first function, which is the 5, plus the integral of the second function. So like we did for derivative, we were able to break the sum. We can do that with the antiderivative. We break the sum. All right. Let's do them step by step. What's the antiderivative of 5 dx? 5 is a constant. So I can pull it out, and I will have integral of dx plus 3 over x. 3 is a constant. So 3 over x is nothing more than 3 multiplied by 1 over x. That's really what 3 over x is. So this is going to allow me to pull the constant out times 1 over x. Okay. And now this is done. It's 5 times antiderivative of dx, means the function whose derivative is 1. So antiderivative of dx, it means 1 dx, that's a 5x, plus 3. Antiderivative of 1 over x is ln of x. Now I don't add a constant every time. I just, at the end, I say plus a certain constant c, where c, I remind you, it's a constant. It means it does not depend on x. That's what it means. I will do 2 more. Yeah.
How'd you get that ln the absolute power, absolute x?
Here?
Right there?
Yes. That's the antiderivative of 1 over x. If I forget about the absolute for a second, all right? What's the function whose derivative is 1 over x? You hear me?
What did you say? I'm sorry, I couldn't hear you.
Okay. What is the function whose derivative is 1 over x? Remember, antiderivative, it means I'm asking the following question. Which function, go back in your mind to all the functions we find their derivative. What is the function whose derivative is 1 over x?
Wouldn't that be ln of x plus
That's
c?
ln of x. Yes. Exactly. Now, we can prove, I didn't show it to you, but we can also show you the following. We can prove the following, that if instead of x, I take the absolute value of ln of x, which is a new function, its derivative is also 1 over x. Okay, so derivative of ln is 1 over x, as long as x is positive. And the derivative of the, even if instead of x, I put the absolute value of x, so we can prove the following, is also 1 over x. And since we always try to find the most general answer, so the antiderivative of ln of 1 over x is the ln of the absolute value. Okay?
All right, thank you.
Okay, so now, 2 more problems, actually 3, and then we proceed. So I'll give you a minute to do that. So you see if you guys are interacting well with me. Plus x plus 3 over x cubed dx. Okay. You know, if you have a sketch piece of paper, why don't you give yourself, I give you a minute and do it, and then I'll take it from there. So you guys start seeing if you're doing any mistakes. Are you guys ready? Okay, what do you guys get for the first one? What's the antiderivative of 1 over 2x? So first I split them because I can. We have a sum in here. And then what did we get for the first one?
1/2 of the ln of the absolute value of x.
Right, because 1 over 2x, how can we write it? It's a half times 1 over x dx. So we can try we isolate the constant. This is 3 times 1 over x cubed dx. So I'm doing my best to isolate the constant. This is a constant. It becomes a half integral of 1 over x dx. And that's become 3 integral of 1 over x cubed has to be rewritten x to the minus 3. Now I am prepared for everything. There is nothing than, you know, connecting stuff. So that's the ln. And this one, that's the n is minus 3. So I am very safe. So it's 1 over minus 3 plus 1 x to the minus 3 plus 1. So finally, this equal to minus 3 plus 1 is a minus 2. Then x to the minus 2 plus c. And of the problem. Okay. Now, suppose I give you the following. Antiderivative of x. Let me take a nice piece of x times the square root of x dx. Okay. Let's find what's the antiderivative of this function. It doesn't look like something we've seen immediately, but what can we do with it to be able to figure it out?
We could combine exponents.
We can combine exponents. Actually, that's the only way out. X times square root of x is x times x to the power a half dx. Means combining constant exponent, 1 plus a half, 3/2 dx. Okay, I cannot break it. I'm going to make a big remark now that we can only break the definite indefinite integral if we have a sum. We can't break it if we are multiplying. Absolutely not. And then I will mention that in a second. So this is going to be equal to, now this is the n, it's 3/2 is going to be 1 over 3/2 plus 1, x to the 3/2 plus 1. And the rest is algebra. 3/2 plus 1 is 5/2. So this is 5/2. So 1 over 5/2 is going to give me 2/5. X to the power 5/2 plus c. End of the problem. Now, this is going to make me give you the following remark. As I said previously, property of the integration was that I can break the indefinite integral as long as I have a sum. That's the rule. I cannot, like I did for the derivative. Remember, for the derivative, if I have the derivative of the product, this is not f prime g prime. I cannot break the derivative if I have a multiplication. I have a product rule. For integration, also the same thing. It means if I'm multiplying two functions, I cannot break the multiplication. So this is not this times that. Absolutely not. So I cannot break if I have a multiplication. I only can break the indefinite integral, like I did for like differentiation. For derivative of the product is not product of the derivative. There is an absolute product rule to use. And in integration, eventually we will have something similar to that. But for the time being, I cannot break if I have multiplication. This doesn't work. And let's take, for example, very simple example. Suppose I take the integral of x times x dx. Big deal. So this is integral of x squared dx, which is 1/3 x cubed plus c. If I break it up, I'm going to get a 1/2 x squared times a 1/2 x squared. It's going to give me 1/4 x4. Absolutely doesn't work. Okay, so we have to be very careful. We don't make up our own rule. So we can never split the product. We have to manipulate the product like we did a minute ago to be able to find it. All right, so my last example for that is the following. Integral of 1 plus x squared over the square root of x dx. Again, we cannot, the same way we cannot break a product, we cannot break a quotient, a ratio between two functions. That's because it fails for the derivative as well. So what do you want me to do with this mess?
Should we manipulate the powers then? Like the bottom one, we make it 1/2.
Okay, I can do that. I can do that. And then
well, we subtract the x over x to the power 2 from x to the power 1/2.
what about the one?
Never mind.
You're half right, not fully. Right, make it this one. Okay, so one way you can do it, there are two ways. One way is the following. So I'm going to do it two ways. Either way will be the same. One way you can say this is equal to that. So this is one way. Then I would plus x squared. Is this correct? Am I correct here? So you guys will have to do that. So divide by x to the half is like multiplying by x to the minus a half. So this is going to become equal to, I distribute, because I have a product, I cannot do anything. I have to make it into a sum. I distribute x, 1 times that will give me x to the minus a half plus x squared times x to the minus a half. I combine the powers, give me 2 minus a half x to the power 3 half dx. Okay, I have to manipulate algebraically to make it into a sum so I can really work with it, because I don't have rules to deal with a function over another. And now I split, and then I proceed. Okay, let's split this one. Now it's basic. My n here is minus a half, so I will get 1 over minus a half plus 1 x to the minus a half plus 1 plus my n here is 3 halves, so I will have 1 over 3 halves plus 1 x to the 3 halves plus 1 plus my constancy. And the rest is simple. The rest is pure algebra. Minus a half plus 1 is 1 half. 1 over a half, it's a 2. X to the power a half plus 3 halves plus 1 is 5 halves. 1 over 5 halves is 2/5. X to the power 5 halves plus. Okay. So whenever I have a product of functions, at least for now, we're going to learn a lot of rule, but this is for this problem like this, that's the only way we can find antiderivative. Or we are dividing, we have to manipulate so far to be able to use what we know. We don't make up our rule. Our rule, we have very few rules that we can use. We can split a sum, and if you have a constant times a function, we can take the constant out. This is about the only rules we have so far. Okay. So now we're going to list some basic antiderivative that you guys should be able to give me the answers without really a lot of thought. So basic antiderivative or basic indefinite integral. Okay. So I did the main one, which is the power rule. Those are simple. So what's the antiderivative of cosine x dx? Means always remember, what is the function? When I differentiate, I get cosine. That's really what my question is. So quick answer and quick. That's the sign. Absolutely the sign. Because differentiating the sign give me the cosine. Okay. Remember, don't confuse that with the derivative of cosine. The derivative of cosine is minus sign, but the antiderivative is the sign, because derivative of sign is cosine, and plus, of course, the constancy of integration. Now, what's the antiderivative of the sign? Means what is the function? When you differentiate, you get the sine of x. Okay. Back to you. Which function we differentiate? Now, of course, it has to be the cosine, because only the cosine will give you the sine. but the derivative of cosine is minus the sine. So to compensate for that, I need the minus in here. So antiderivative of sine is minus cosine plus c. Very good. Now, what other basic functions we'll have? What's the antiderivative of e to the x dx? Absolutely. Okay. Again, what is the function? When we differentiate, we get ex. That's really what I am after. Quickly, all of you. Which function, when I differentiate, I get ex? E to the x itself. So antiderivative of ex is e to the x plus c. Okay. One more. And those are basic. I call those basics. So all the rules we're seeing them are the basic. Now this one, which is, I consider it basic because it comes up a lot. What is the function? Now scratch your head a little bit. What is the function? When I differentiate, I get 1 over 1 plus x squared. Okay, there is one more, and I am done with the basics. Try to remember what function. When we differentiate, you get 1 over x squared. That's the arc tangent x. Again, this is a function that comes up a lot, so that's why we call it basic antiderivative plus c. Those totally have to be, basically they have to be memorized. And I told you before, if it was face-to-face, you guys will never have access to anything. Finally, 1 over the square root of 1 minus x squared dx. That's the last basic antiderivative that it's important, not as much as this one. This is used a lot. And so it means what is the function? When we differentiate it, we get that. Anybody remember? I know that you guys can forget this stuff, but anybody remember this one? Okay, I remind you, that's the arc sine. Okay, that's the arc sine. So yes, that's the arc sine. Plus, okay, because the derivative of arc sine is that. So those are absolutely the basic antiderivative. And believe me, that's the only one you will ever memorize. There is no other antiderivative that you need to memorize, except those and the power rule. And every other antiderivative, we work it out. So these are the ones that I would love you to just memorize them. I know that you guys can look things up in this, the way we're learning now, but you should memorize them. They are very, very crucial for you to memorize. Okay. So now I can give you like more functions to find their derivative. So I tell you, for example, find the antiderivative of 2 sine x plus 3 cosine x dx. So now I can have more and more function where I can find the antiderivative. So this would be fairly simple by now because it's a sum. Being a sum, I can split because it's a sum. And this being a constant can be taken out. Done that. Now I'm done. Antiderivative of sine x is minus cosine. So here there is a tendency of us forgetting the derivative of cosine. The derivative of sine is cosine, but the antiderivative is minus cosine. So try to keep that in mind. And then this is nothing more than the sine plus c. So now we can find the antiderivative of a whole new class of functions, actually quite a bit of them. Okay. So I stop right here for this section, not for this section. I still have something to talk. I'll talk about it tomorrow. Now for tomorrow, of course, you guys have the review. Did you start? Yes or no?
Yes.
I hope you guys did start. Okay, so
Yes.
tomorrow I will answer any questions you have. So please come with questions. I will have the review and will answer every questions you have about the review. And in the remaining time, I still have an idea to talk about concerning this section. But please come with question tomorrow. Is that very clear? There is part that I did not explain, but I know that Dr. Beer did a good job. So, but it's crucial. I mean, it's you have to know it. So please come with questions tomorrow. The exam, I would like to start it, as we always do, I think, at 7:30. Are you guys ready for it? Are you guys ready to start at 7:30?
Sure.
Nobody is
let's do
ready?
it.
What?
Let's do it.
We do it?
Yes.
Everyone?
Yes.
Everyone? I hear one yes. How about all of you?
7:30 it is.
7:30. Okay. I'm gonna wake up early also. It's not only you, but I don't have to think like you. Anyway, so we will start it at 7:30. So you guys will have enough time till 9:30. But please come with questions tomorrow and I will answer any questions you have. And I have office hours also. Please show up on my office hours. Okay? All right. I'll see you tomorrow, guys. So for tomorrow, I will not assign. I'm not going to include this section in your exam because you have plenty to work with. This section, my plan is to give you a quiz on it on Tuesday, the day before we take off for Thanksgiving, just to make sure you guys are learning it. So I will not assign homework for tomorrow about this section. I will assign homework about this section for Monday, which would give you time to work on it. Okay. However, I want you to prepare for your exam and ask me questions tomorrow. Is that clear? Okay. Bye-bye for now. And if you have questions, welcome to my office hours. Bye-bye, guys.